There are buyers who will pay $500,000 for a single remote code execution bug in WordPress. Well, a security researcher just found one and it cost him $25 in AI tokens. 2 web requests, no login, no plugins, no credentials, just a stock WordPress install, and a full remote code execution. So this comes to us from a security researcher named Adam Hughes, and the way he found this was a little extra cool to me because I have a math degree, but don't worry, there's no math happening here. When GPT 5.6 Soul edition dropped, he noticed that OpenAI had published the prompt they used to solve a famous math problem called the cycle double cover conjecture. Yeah, I know it's a mouthful. Adam looked at the prompt though and thought, if this thing's good enough to solve hardcore math problems, maybe it's good enough for security research. So he adapted the prompt, pointed it to the WordPress source code, gave it 4 agents, and told it to spend at least 6 hours looking for a 0 day. He purposefully restricted it too. No changelogs, no git history, no internet, so it didn't distract the agent. Just read the source from first principles. He came back to a pre-auth SQL injection and didn't believe it. WordPress is one of the most hardened targets out there. It's heavily scrutinized. It hadn't had a meaningful pre-auth vulnerability in 9 years until this event. So he installed a stock WordPress instance and asked the AI to prove it. A couple minutes later, it printed the admin's email, so it was legit. WordPress runs on something like 500 million sites, and this bug sat in the core, not in a plugin, not in a theme where we usually see these. And it hit a very small, weird window of versions, 690 through 694 and 700 through 701. When WordPress realized what they were dealing with, they did something rare. They reached into millions of sites and force installed the patch via the auto update system. That's the setup. Now let's go through the actual chain because the SQL injection is just one of 7 very interesting events that happen here. So the door is a feature you probably never heard of, which is the REST API's batch endpoint. So WordPress has a batch v1 endpoint, lets you send multiple API requests in one call. Update 5 blog posts at once kind of thing. Now, when you hit a normal WordPress API endpoint, it runs a 4-step check on every call. Validate the shape, sanitize the input, check permissions, and then execute it. The key is that everything gets validated before they reach the endpoint. The endpoint trusts the validation already happened. The batch endpoint does this a little differently. Normally, validation and execution are glued together for a single request. Batch unglues them into 2 loops over the same list. First loop for validation walks every sub-request checked in and records a pass or a fail. The second loop over here is the execution. It walks the list again and runs each one time. So it keeps the 2 arrays in lockstep with each other. Position 0 to 0, position 1 to 1, so on. As long as they stay aligned, every request runs as the thing it was checked as. So picture a valet. He's got 2 clipboards in sync with each other. Clipboard 1 is every car that pulls up, pass or fail. Clipboard 2 is which bay that car goes into. Same thing is here. Bay 0 for car 0, bay 1 for car 1. Well, WordPress-to-Shell slips in a malformed request, a car that can't be logged properly. It gets a line on the clipboard 1, but nothing on clipboard 2. So now we've got a gap. Everything after that is off by 1. You check in a Honda and you get out a Mercedes. So that's a stage 1 bug. You validate 1 request and then execute it with a different endpoint's handler. So it's a route confusion in the beginning. So where do we point the desync bug? Well, the AI found the posts API endpoint used to get a list of posts for the site has a parameter called author exclude. Normally, this parameter has to be an array of integers, and WordPress runs it through an absent function, basically turn this into a positive number. But there's a bug in the code. If the input is an array, it gets sanitized. If it's a scalar, a single string, it goes straight on into the SQL query with no escaping. Normally, you can't reach this because the post endpoint validates author exclude is an array before it gets to the query. But, and it's a big but, with our route confusion, we can bypass that validation entirely. We can validate against a different endpoint that doesn't even recognize the parameter, then execute on the post endpoint where it drops into raw SQL. There's one more problem here though. The batch endpoint doesn't support an HTTP GET request, and the SQL injection is only reachable via the GET request. So the AI did something else tricky. It nested a batch call inside a batch call. We got Batch-ception happening here. 2 levels of route confusion to smuggle a GET request through to the SQL injection sink. Now that's stage 2. Validate on one endpoint, inject on another. We have an unauthorized blind SQL injection into the WordPress core now. Now here's where it gets absurd. The SQL injection is bad, but it's read-only here and it's blind. You can leak data, but you can't run commands. So to get RCE, the AI had to build a chain through WordPress's caching system, and this chain is honestly insane in the membrane. Stage 3 is all about cache poisoning. WordPress has an in-memory caching system for all the post objects during a request lifecycle. If the same post is referenced multiple times, WordPress uses the cache version instead of hitting the database. And since we have a SQL injection, we can use a union injection to send back fake posts, completely fabricated rows that WordPress will happily cache, and we control everything about the cached post. So now that we've poisoned the cache, we've got another problem. It's in memory. It dies when the request ends. We need something persistent. Honestly, this whole thing is feature abuse. WordPress has another feature called embeds. So when you put the little embed tag with the square brackets around a URL, you drop it in your post, WordPress fetches that URL and embeds the content inline. To avoid making the HTTP request every single time, WordPress caches embeds in the database as real rows in the post table with a type called oembed cache. Here's the kicker. You can embed your own posts. So given a relative path instead of the full URL, and WordPress treats it as if it's local, no web request. But, and it's another big but, I'm talking dump truck territory here, it never checks whether that post actually exists. So we have our SQL injection to return a fake post that contains embed links pointing to post IDs that don't even exist, and WordPress happily creates a database entry for them. And we can fabricate rows in the database using a read-only SQL injection. Oh, that's nasty. Now we have real database rows that we also control in memory, and when the cache version and the database version disagree, WordPress has to reconcile them. So here's where the chain goes from clever to what the French toast. WordPress has another feature called change sets. So when you're editing your site's theme, for example, WordPress saves your draft changes as a JSON blob in a post with the type of custom change set. Each change in the JSON has a key, a value, a type, and more importantly, a user ID. That sets the authority of what's to be used when you're applying the change. So when a change set gets applied, WordPress does something understandable, but also uncomfortable. It calls WP set current user as the user in the change set. It temporarily becomes that user. If the change set says user ID 1, you become the administrator for the duration of that request. So the plan is to fabricate a change set with user ID 1, get WordPress to apply it, and then we can temporarily impersonate the admin. But there's another catch.
Always a catch.
When WordPress reconciles the in-memory cache with the database rows, it explicitly overrides post content, the field where the change set lives. We control what's in the cache, but the post content gets stomped by what's actually in the database. We can't control what's in the change set payload. So we hit a dead end. Psych, no, we didn't hit a dead end. WordPress thinks of posts as a tree. Each post can have a parent, and you walk up the tree to the root. But what if the tree has a loop in it? Post A's parent is B, and B's parent is A. You get an infinite cycle in there, an infinite loop. WordPress anticipated this. If it detects a cycle, it calls the WP update post function to set the parent to 0 and break the loop. And here's a critical difference. This is a different call to WP update post than the reconciliation call. The reconciliation call overrides the post contents. The cycle detection call does not. So the AI set up a cycle in the post hierarchy. WordPress detects it, calls the WP update post function to fix it, and in that call, our fabricated post content, the one containing our admin change set, gets written to the database. The one field we couldn't control before now is ours. We now have a change set in the database that says, apply these changes as user ID 1, the administrator. When WordPress applies it, we temporarily become admin. We can modify posts, change settings, do anything the admin can do. But only while the change set is being applied. Then our rights revert back to anonymous. So we now have a brief window of God mode. How can we make it permanent? WordPress has a plugin system built on hooks, little tripwires that fire at almost every point in the lifecycle. And when a post changes status, WordPress builds a hook name on the fly. It glues the new status and the post type together with an underscore and fires whatever that string is. It's just a simple concatenation. So we fabricate the post, we control both halves of the name, we can then make WordPress call any action hook that contains an underscore as the administrator. So the exploit aims it at parse request. That's the hook at the very start of the request lifecycle. calling it replays the whole request, except this time, we're still the admin. And boom goes the dynamite. With admin privileges, we can write PHP files to the server, we can run commands, full shell from anonymous to code execution in 2 HTTP requests. Let's recap the chain real quick. We get a route confusion to a SQL injection to a cache poisoning to an embed fabrication to a change set identity theft to cycle detection bypass to a hook dispatch, each stage handing off to the next one. Now let's talk about the how for a second, because the methodology here is worth understanding. Adam didn't just tell GPT-5.6, go find me a bug. No, he gave it a structured prompt. He adapted it from OpenAI's own math research prompt, and he gave it very specific rules. Use 4 agents. Don't fix them to any one approach. Maintain a diverse portfolio of approaches. Explore input parsing, char sets, file uploads, error handling, race conditions, serialization, the whole shebang. Don't let one approach dominate just because it looks promising. And when an approach stalls, mark it blocked and only revisit it if one of the agents proposes a genuinely new mechanism. And use adversarial agents to double check every finding. He also gave it a time limit. He said, I want you to spend at least 6 hours on this and don't stop after the first wave fails. Exploit brokers, they would pay up to $500,000 for this kind of an exploit. He found it for 25 bucks. 50% of his weekly usage on a $200 per month subscription. Adam himself said, I was astonished by several creative exploitation techniques that I would have previously thought were the domain of humans. Specifically, the recursive batch to bypass the HTTP GET restrictions, and the cycle detection reconciliation trick. Those are not obvious, and they're the kind of multi-step logical leaps that experienced exploit developers make after years of working on code bases. Now, I'm going to be straight with you. This doesn't mean AI is going to be replacing security researchers tomorrow. Adam figured out exactly how he was going to prompt the model based on humans figuring out how to prompt other models and how to structure the search and how to verify the results. GPT did find the chain. Adam did have to go in and untangle it, and admittedly that took him much longer than the model spent writing it. The AI is a tool, a really good tool in the right hands, but still a tool, and the tool's only as good as the wielder. If you give the worst weapon to the best marksman, he's going to shoot better than the worst marksman with the best weapon. And if you enjoy watching an AI build a 7-stage exploit chain for the price of lunch, please perform a blind SQL injection on the Like Button's WordPress site, extract the admin password hash, crack it, change the password, and then replace the wrong password error page with a picture of Indiana Jones that just says no ticket. That's all I got for you guys. I will catch you on the flip side. I love you. Peace.